Alright, welcome back Physics 40B to another explainer video. This is explainer video number 18.50 and this is referencing week 6. Week 6, we're basically going into the macroscopic description of matter. Basically, we need to understand this thing called the ideal gas law. And a pro tip from me that really helped me get through this, because I like cars and I'm familiar with engine cycles, to learn how four-stroke engine cycles work. This will help you understand the ideal gas law just a little bit better, and it's pretty interesting nonetheless. But anyway, let's get right into it. So this is 18.50. Make sure you're doing the right one. So let's start off with the conceptual question. How do we model gases? If only there was an equation that we could use that existed, I guess, that modeled ideal gases in just an equation that modeled ideal gases. Oh wait, there is. It's right there. P, pressure times volume, is equal to the moles times ideal gas constant times the temperature. We got one, so let's use it. So here's the question. We have a 3-meter long pipe, if shown in figure 18.50. The figure's down here. It's closed at the top end. It's slowly pushed straight down into water until the top of the pipe is level with the water surface. And it's asking, what is the length L of the trapped volume of air? So just by looking at it, we can assume that it's going to be about, 2.4, 2.5. If you just break it up into little fractions. But let's actually figure this out. So we know that the initial length is 3 meters. And we know that the pressure initially is atmospheric pressure. And we also know it's an ideal gas. So that's good. So now let's just get into the math. And I didn't want to do all the math typed out because I feel like it's a little bit confusing. So I just wrote it out and I'm going to get into that. But I just saw this meme. I thought it was hilarious. How pi is equal to 5. What the fuck is that? That does not make any sense. That's hilarious. But anyways, here we go. So we know the ideal gas law. I wrote it down right there. And I wrote down what each of those variables mean. R is the gas constant. And then this is so that was step 1. Just writing down all the things that we know. Step 1.5, I labeled it, just setting up this equation. So we know that the initial pressure times the volume is going to be the same as the pressure when it's inside times the volume of the inside. Because the volume will decrease, the pressure will have to increase. They're inversely related. So we know that they're equal to each other. This volume might be different from this volume, and this pressure might be different from this pressure, but essentially together they are the same. So we know that pressure 1 is 1 atmosphere, and that's just this number, pascals, right? I don't what is that? 101,325 pascals. And then we know that V1 is just the area of the cylinder times the length. And then we don't know the area, or the circumference or whatever, but we know the length, so it's just A times 3 meters. And then V2, same thing, A times L, but we don't know L or A. We're trying to find out L. And don't be confused by this A. It gets canceled out later. So just honestly, it's just L. We know L is 3 in this one. Okay, so since we know the temperature remains constant, we can set the pressure and volume equal. That's what I did over here in this one. Pressure and volume are equal because the temperature is constant. That we're able to do that because the temperature is constant. And then we know that just the pressure inside of it is equal to the initial pressure plus the pressure of the water, which is modeled by rho GH, or rho GL in this case. H and L are interchangeable. And that's just the formula for pressure. And then we insert our knowns into, into the little one. This is 1 over here. So, and our knowns are back here. We're just going to put these values into that equation, and it's going to look like this. We're going to distribute the AL over to here, and then we get this. Subtract the 3A P1 to both sides, and we get this. So we're looking for L, right? So we have L squared, L, and we have no L here. This is a quadratic equation. So if you don't know what that looks like, we need to use the quadratic formula. If our variable was x, in this case our variable is L, our unknown is L. If it was x, it would look like this. You take the x out, and the x is going to be equal to the coefficients. I'm sure you guys all know how this works. So we have L outside, and we take the L off all of the coefficients, and we just plug in the values. I'm not going to go into it, but I'm sure you know how I got to this point. And then literally from there, it's literally plug and play. You got to plug in your values. All your P1s, you put in 101,325 pascals. All these A's, this A canceled this one in here. These all get canceled out. And you're just left with numbers, and you just calculate those, and then we just get meters. and you plug this whole thing into your calculator, or you just solve it out by hand if you're crazy, and you get 2.4 meters. So I guess I was right. And that's about it. Good stuff. Thank you.